Hello, I'm Brian Young, and today we're doing Module 26108, Wireways, Raceways, and Fittings. Let's get started. 26108, Wireways, Raceways, and Fittings. Successful completion of this module prepares you to do the following. Explain how to select and install Raceway systems. With that, you'll identify conduits types and their applications, describe how to properly bond conduit for the use as a grounding path, describe how to install metal conduit fittings, describe how to make conduit to box connections, identify raceway supports, identify installation requirements for various construction methods. You'll also learn how to explain how to select fasteners and anchors for the installation of raceway systems. Explain how to select and install wireways and other specialty raceways. Explain how to select and install cable tray, and describe how to handle and store raceways. And your instructor will have you do some performance profiles, identify the appropriate conduit body for a given application, identify and select various types and sizes of raceways, fittings, and fasteners for a given application, demonstrate how to install a raceway system, and terminate a selected raceway system. Overview. Electrical raceway systems protect cables, wires, and bus bars. It's important to know how to correctly select and install the systems for many safety reasons. You can learn proper installation skills for raceway systems through practice, knowledge, and training. In addition to describing various systems available, this module will teach you how to select and install the systems based on National Electrical Code requirements. It also describes how different types of conduit are used for raceways. 1.0.0 Raceway Systems. The term raceway refers to enclosed channels used to house electrical wire. Raceways can be metallic or non-metallic and come in different shapes. In this section, you'll learn about the types of raceways, including enclosures such as flexible metal conduit, tubing, wireways, surface metal raceways, and surface non-metallic raceways. You'll also learn about support systems such as cable trays. Raceways. Closed channels designed expressly for holding wires, cables, or bus bars with additional functions as permitted in the NEC. So let's take a look at what the NEC tells us about raceways. Here's the table of contents. Article 100 is definitions. Let's take a look at the definition of a raceway. Let's see here, where am I? So we go to Article 100 and we scroll down till we find raceways. Raceways, an enclosed channel designed expressly for holding wires, cables, or bus bars with additional functions as permitted in this code. And then they go on to describe some of these raceway systems. A raceway cell is a single enclosed tubular space in a cellular metal or concrete floor member, the axis of which the cell is parallel to the axis of the floor member. So they have some preformed slabs. They can either be concrete or metal. When they pour them, they actually have these channels, these openings in them. It makes them lighter, doesn't necessarily take away too much of the strength of the preformed slab, but it makes them lighter for transportation, what have you. So they're made somewhere else, and they are moved to the job on usually a flatbed truck, moved around with a crane. And you can use one of those channels as a raceway. Here's cellular metal floor raceways. The hollow spaces of cellular metal floors, together with some suitable fittings that may be approved and as enclosed channels for electrical conductors. Communications raceways, an enclosed channel of non-metallic materials designed expressly for holding communications wires and cables optical fiber cables, data cables associated with informational technology, and communications equipment, Class 2, Class 3, and Type PLTC cables. That Type PLTC, that's plenum rated tray cable, plenum. So now we're wondering what a plenum is. We might want to look it up. So we'll go, we're already in Article 100 definitions. Let's just look up plenum. Here's a plenum. A compartment or chamber to which one or more air ducts are connected and that forms part of the air distribution system. So a plenum is part of the breathable air. Your air conditioning system might have a plenum or be part of the breathable air. Anytime we're talking about breathable air, environmental air, there are a lot of regulations that go with it. We cannot just put any wiring system in a plenum for return air or for conditioned air. If you put non-metallic sheath cable, for instance, if there's a fire, if that jacket catches fire, it gives off toxic fumes. And you don't want those toxic fumes spread throughout the building through the air system. So we have to use systems inside the plenum that are liquid tight, flexible metal conduit or flexible non-metallic conduit, something that's going to keep them separated. I take it back, excuse me, we would not use liquid tight because the liquid tight actually has a coating on it that also gives off toxic fumes. So it wouldn't be plenum rated as well. We'd use flexible metal raceway with no coating on it. And we could put our conductors inside of that. That would be an approved. We could use rigid conduit or intermediate conduit. They would be plenum rated. There wouldn't be any exchange of environmental air, or not enough to make a difference anyway, or to become a hazard. There's strut type channel raceways, a metal raceway that's intended to be mounted on the surface or suspended from a structure with associated accessories for the installation of electrical conductors and cables. There's surface metal raceways, a metal raceway that's intended to be mounted to the surface of a structure with associated couplings, connectors, boxes, and fittings for the installation of electrical conductors. So all of these raceway systems are for the containment of electrical conductors and cabling. Okay. And a wireway is a steel trough designed to carry electrical wires and cable. 1.1.0 types of conduit and their applications. Conduit is raceway with a circular cross section, similar to pipe, that contains wires or cables. Conduit is used to protect conductors and route them from one place to another. Metal conduit also provides a permanent electrical path to ground. This equipment must be listed in accordance with the National Electrical Code. Be sure to check with local codes. The National Electrical Code allows us to use metal raceways as the equipment grounding conductor. A lot of times your coastal communities require an additional equipment grounding conductor, separate wire pulled into the conduit for the equipment grounding conductor, either solid or bare, solid or stranded, insulated or bare. But they don't rely on the conduit because of salt air. So if you live near a coast, you may want to check with the local code to make sure that you're allowed to use the conduit as an equipment grounding conductor. There are many types of conduit used in the construction industry. Conduit size is determined by engineering specifications, local codes, and the National Electrical Code. NEC Chapter 9, Tables 1, 4, 5, and 5A, and the National Electrical Code Informative Annex C for conduit fill with various conductors.
And it says know the code, NEC Chapter 9, Table 1, NEC Chapter 9, Table 4, and Table 5 and 5A. Informative Annex C. Hopefully we get a chance to take a look at those in the code book. 1.1.1, identifying electrical metallic tubing. Electrical metallic tubing is the lightest duty tubing available for enclosing and protecting electrical wires. EMT is widely used for residential, commercial, and industrial wiring systems. It's lightweight, easy to bend, and easy to cut or shape. This is a highlight. It is also the least costly type of metallic conduit. Here's another highlight. Because the wall thickness of EMT is less than that of rigid conduit, it's often referred to as thin wall conduit. We do not thread electrical metallic tubing. It's too thin to put a thread on the outside. We use either set screw couplings and connectors or compression couplings and connectors. With rigid pipe, you thread it, or intermediate metal pipe, you thread it and use a threaded coupling. You can use lock nuts to adhere it to a box or to fix it to a box. Or if it's outdoors, you can use a Myers hub, which gives a gasketed connector that screws on the end of the conduit, and it makes for a rain-tight seal. Figure 1 shows a comparison of the inside and outside diameters of electrical metallic tubing, rigid metal conduit, and intermediate metal conduit. Rigid is the thickest. Rigid metal conduit. If you're working in a commercial or an industrial environment, you're probably going to be using rigid conduit. It has the thickest wall. It affords the greatest protection for the wires inside. You can see that EMT and rigid share the same internal diameters to an extent. If we look in the code book, we'll see the internal diameters of rigid conduit and electrical metallic tubing, and they're very close. They are not exact. Also, the trade size of the conduit is the internal diameter of the conduit. So if we're talking about a 1-inch conduit, the internal diameter is slightly larger than 1 inch. Might be 1.065 inches in diameter. It might be as much as 1.3 inches in diameter, but it's something greater than 1 inch in diameter. We call it a 1-inch conduit. Likewise, a 2 inch is greater than 2 inch, a 3 inch is greater than 3 inch, but only by a small fraction. Intermediate metal conduit, because it's threaded and uses the same types of fittings as rigid, it has the same outside diameter as rigid conduit. So since it's a thinner walled conduit, it has a larger internal diameter. We will still use the wire fill in Chapter 9, Table 1, and Tables 4, 5, 5A, and 8 in order to determine how many wires we can put inside of intermediate metal conduit. You'll find code related to electrical metallic tubing in Article 358. Specifically, NEC Article Section 358.10 covers EMT installation requirements. Uses permitted. So, electrical metallic tubing, Article 358. So, Article 358 is electrical metallic tubing. So, if we had a question about EMT, we could go back to our National Electrical Code, and here we're in the table of contents. If we go to Chapter 3, it has wiring methods and materials, and as we look down through all of these different articles, we'll find Article 358 is electrical metallic tubing. It's on page 245. So we can go to page 245, and because of the alignment of this, I'm actually going to go to page 248. Oops, where did I go here? There's 48. Let's see if that's... Is that it? Article 358, electrical metallic tubing. And this will tell us uses permitted.
It shall be permitted for both exposed and concealed work for the following: in concrete, in direct contact with the earth, in direct burial applications with fittings identified for direct burial, or in areas subject to severe corrosive influences, where installed in accordance with 358.10b. 358.10b says corrosive environments, galvanized steel and stainless steel EMT elbows and fittings. Galvanized steel and stainless steel EMT elbows and fittings shall be permitted to be installed in concrete in direct contact with the earth or in areas subject to severe corrosive influence, where protected by corrosion protection and approved for as suitable for the condition. So they have to be protected from corrosion, either by enamel or by some kind of cold tar or pitch painted on the AMT, and then you can use them for that application in dry, damp, and wet locations, and any hazardous locations as permitted by other articles in this code, and for manufactured wiring systems as permitted in 604.100A2. So we could go to part 3, which is, let's see, where's the bends? Oh, here it is, 358.24 bends, how made. Bends shall be made so that the tubing is not damaged and the internal diameter of the tubing is not effectively reduced. The radius of the curve of any field bend to the center line of the tubing shall not be less than that shown in Table 2, Chapter 9 for one-shot full shoe benders. So, numbers in one run, the total degrees of bend in any tubing run shall not exceed 360 degrees. That's 4 90-degree pulls. So if you have to go more than 360 degrees, you have to put a pull box. Okay. Reaming and threading, it says all cut ends of EMT shall be reamed or otherwise finished to remove rough edges. EMT shall not be threaded. Okay. And securely fastened, EMT shall be securely fastened in place in accordance with the following: at intervals not to exceed 10 feet, within 3 feet of each outlet, junction box, device box, cabinet, conduit body, or other terminations. So Article 358 is electrical metallic tubing. And here is Part 3, construction and specifications. EMT shall be made of one of the following: either steel with protective coating, aluminum, or stainless steel. EMT shall be clearly and durably marked at least every 10 feet as required in the first sentence of 110.21a. Very good. Article 358. Here's a highlight. It says, according to NEC Section 358.10b1, galvanized steel and stainless steel EMT elbows and fittings can be installed in concrete in direct contact with the earth or areas prone to corrosion, as long as they're protected from corrosion and approved as suitable for the condition. I don't like the way that is written because I think it's misleading. If you only read the first half of the sentence, you would think EMT is good for direct burial. EMT is good for in concrete slabs. It's not. You can't put EMT direct buried or in concrete slabs unless you have a coating of something, enamel or cold tar. You have to put something on the outside of that EMT in order for it to be approved as suitable for those locations. Regular galvanized electrical metallic tubing is not permitted to be buried or installed in concrete. For NEC Section 358.10d, where EMT is installed in wet locations, the supports, bolts, straps, and screws must be made of corrosion-resistant materials or protected against corrosion by corrosion-resistant materials. NEC Section 358.12 covers the uses not permitted for EMT. It states that EMT must not be used where it may be subject to severe physical damage. In addition, it may not be used to support luminaires or other equipment, except conduit bodies no larger than the largest trade size of the tubing. So we use
down rods to support ceiling fans, and they're 3/4 inch rigid. You can buy them in any length. Oh, they have certain lengths you can get. I think they're even inches, 2, 4, 6, 8, up to a foot, and then I think it's 18 inches, and then it's 2 feet. I'm not sure how long they will sell them. You can make down rods any length you want. If you have a piece of 3/4 inch rigid or IMC, you can thread it to the standard thread, the NPT National Pipe Taper, and it will work as a down rod for that ceiling fan or for a lighting fixture. So if you had a customer who had extremely high ceilings and they wanted a 7-foot or 8-foot down rod, you could make one out of 3/4 inch rigid. You cannot use EMT to support fixtures or ceiling fans. It's not adequate and it's not threaded. It has a compression or a set screw connector on it, which can vibrate loose, and then the ceiling fan will fall out of the ceiling. In a wet area, EMT and other metallic conduit must be installed to prevent water from entering the conduit system. For NEC Section 300.6D, in locations where walls are frequently washed, the entire conduit system must be installed to provide a 1/4 inch gap airspace between it and the wall or supporting surface. The entire conduit system is considered to include conduit boxes and fittings. To ensure resistance to corrosion caused by wet environments, EMT is galvanized. The term galvanized is used to describe the procedure in which the interior and exterior of the conduit are coated with a corrosion-resistant zinc compound. They sell cans of cold galvanized. It's like a spray paint. And if you're on a job and you make any alterations to pipe where that galvanized coating is scraped off, especially rigid or IMC, you can spray that cold galvanized back on it and repair it so that it's still resistant to corrosion. Since EMT is a good conductor of electricity, it may be used as an equipment grounding conductor per NEC Section 250.118A4. Again, check with your local codes. They might have established a rule saying you have to go better than the National Electrical Code. Municipalities are allowed to go better than the code. If they've adopted the code as their law, you can't go less than the code, but you can always go above and beyond. The conduit system must be tightly connected at each joint, provide a continuous grounding path from each electrical load to the service equipment. Connectors and couplings used in an EMT system ensure electrical and mechanical continuity throughout the system. See sections 250.96, 300.10, and 358.42. Know the code, types of equipment grounding conductors, section 250.118, bonding other enclosures, 250.96, electrical continuity of metal raceways, cable armor, and enclosures, Article 300.10. Because EMT is too thin for threads, you must use fittings such as connectors and couplings listed for EMT. When EMT compression connectors and couplings are used, they must be securely tightened. Let's see here, let me go on. NEC Article 100 defines rain tight as constructed or protected so that exposure to a beating rain will not result in the entrance of water under specified test conditions. It defines a wet location as a place that is one or more of the following: either unprotected or exposed to weather, subject to saturation with water or other liquids, underground, or in concrete slabs or masonry in direct contact with the earth. You can use wet location fittings in a dry location, but you may not use dry location fittings in a wet location. Wet or damp locations use listed compression cup fittings, such as the ones shown in Figure 2. These fittings contain a compression ring made of metal that forms a rain-tight seal. I believe that the connectors and couplings that are good for direct burial in concrete are black in color. These are set screw couplings. You can see these screws tighten up against the pipe, and it keeps the coupling from coming off, keeps the pipes together. EMT connectors smaller than 2.5 inch, although they're the same size as RMC threadless connectors, may not be used to connect rigid metal conduit. EMT size is 2.5 inch or metric designator 63 and larger have the same outside diameter as corresponding sizes of galvanized rigid metal conduit. Rigid metal conduit threadless connectors may be used to connect EMT. Both set screw and compression couplings are available in die cast or steel construction. Steel couplings are stronger than die cast types. It says Article 358.30 presents support requirements for EMT. I believe you have to support it within 3 feet of a box. If that box is independently supported, if it is not, then I think it's within 18 inches of the box. I'd have to look it up to be sure. As with most other metal conduit, EMT must be supported at intervals not exceeding 10 feet and within 3 feet of each outlet box, junction box, cabinet fitting, or terminating end of the conduit. Exception number 1 allows the fastening of unbroken lengths of EMT to be increased to a distance of 5 feet where structural members do not readily permit fastening within 3 feet. Electrical nonmetallic tubing is also available. It provides an economical alternative to EMT, but it can only be used in certain applications. Electrical nonmetallic tubing is plastic, it's corrugated. When it first came out, it was blue in color, so it got the nickname Smurf tube. Now it comes in all different variety of colors. They have red for fire alarm and yellow for communication and green and blue and whatever you need. You can use those different colors on the job. 1.1.2, identifying rigid metal conduit. Rigid metal conduit is conduit constructed of metal with sufficient thickness to permit the cutting of pipe threads at each end. Specific information related to rigid metal conduit may be found in Article 344. Rigid metal conduit provides the best physical protection for conductors of any of the various types of conduit. Rigid metal conduit is supplied in 10-foot lengths, including a threaded coupling on one end. For shipping reasons, the length of the rigid metal conduit is about 9 feet 11.25 inches or thereabouts. When you screw a coupling, a rigid coupling on the end of that conduit, from the end of the coupling to the end of the conduit at the other end is 10 feet or less. That's because in shipping, you buy your freight by the foot, and you could put 10 feet of conduit on a train. If it was 10 feet 1 inch, if the pipes were exactly 10 feet long, and then they put a coupling on it, and it was 10 foot 3/4 of an inch or 10 feet 1 inch, they'd pay a lot more for the shipping of that product just because of that 3/4 of an inch or 1 inch. So they shorten it by that amount so that when the coupling is screwed on, the length of the conduit is exactly 10 feet long. Here's a highlight. It says rigid metal conduit may be made from steel or aluminum and may be stainless, galvanized, or enamel coated inside and out. Because of its threaded fittings, rigid metal conduit provides an excellent equipment grounding conductor as defined in NEC section 250.118.2. A piece of rigid metal conduit is shown in figure 4. The support requirements for rigid metal conduit are presented in NEC section 344.30 and NEC table 344.30b. So here's rigid metal conduit. These caps they will tell you what size conduit it is. If it's an even inch or in even half inch, it's black. So half inch, inch and a half, 2.5, those have black caps on them. If it's 3/4, it's a red cap. So a 3/4 or inch and a quarter, those are the red caps. Even inches or 2 inches or inch and a half, I'm sorry, 1 inch, 2 inch, 3 inch, those are the blue caps. So half, inch and a half, 2.5 is black, 1/4 or 3/4 are red, and even inch increments are blue. 1.1.3, identifying plastic coated rigid metal conduit. This is steel rigid metal conduit. It's galvanized steel. So sometimes they call it RMC, sometimes they call it RGC for galvanized. In some locations, you have to have a PVC coating on the outside of this conduit in order to protect the pipe against corrosion. If you're in any kind of mines, or if you're working at a nuclear power plant, if you're working at industrial facilities. I was working at an orange juice bottling plant where they make orange juice and bottle it. It was Tropicana down in Bradenton, Florida. They used a lot of Plastibond or Rob-Roy. There are different names for it by the different manufacturers, but plastic coated RMC has a thin coating of polyvinyl chloride, as shown in figure 4B. This combination is used for when an environment calls for the ruggedness of rigid metal conduit along with the corrosion resistance of rigid non-metallic conduit. Plastic-coated RMC requires special threading and bending techniques. Typical installations where plastic-coated rigid metal conduit may be required are chemical plants, food plants, refineries, fertilizer plants, paper mills, wastewater treatment plants. So they said 4B, figure 4B. Here's 4B. Okay, those are plastic coated. I thought they looked plastic coated. These are plastic coated rigid metal conduit. So here's what rigid metal conduit looks like. It looks like steel, and then these are plastic coated. And again, on the job site, they might call it Rob-Roy, or they might call it Plastibond. There's another name.
Rigid metal conduit, Article 344. Let's take a look. Here's Article 344, rigid metal conduit. And it states galvanized steel, stainless steel, and red brass rigid metal conduit. Galvanized steel, stainless steel, and red brass rigid metal conduit shall be permitted under all atmospheric conditions and occupancies. Aluminum rigid metal conduit shall be permitted to be installed where approved for the environment. So we can go on to construction or bends, how made. Bends of rigid metal conduit shall be made so that the conduit will not be damaged, so that the internal diameter of the conduit will not be effectively reduced. The radius of the curve of any field bend in the center line of the conduit shall not be less than that indicated in Table 2 of Chapter 9. Numbers in one run, 4, 360 degrees. The total degrees of bend in a conduit run shall not exceed 360 degrees between pull points. If you need more degree of bend than that, then you put a pull box in the middle of the run. Reaming and threading, all cut ends shall be reamed or otherwise finished to remove rough edges. Where conduit is threaded in the field, a standard cutting die with a 1 in 16 taper, that's 3/4 of an inch per foot, that's the National Pipe Taper, NPT, shall be used. PVC coated rigid metal conduit shall be threaded in accordance with manufacturer's instructions to prevent damage to the exterior coating. So if you have PVC coated rigid metal conduit, a lot of guys will just take their pocket knife and pencil. They'll cut off that cutting, the covering of PVC about 1.5 inches back on the pipe, and then they'll thread the pipe as usual. You don't want to leave too much of the pipe exposed. You don't want it to be susceptible to corrosion in severe environments. And you don't want to leave that coating on when you thread because it gets clogged up in the threader, and sometimes it has a tendency to make the entire PVC coating
slip on the pipe, it could come loose and actually start turning up separate from the rigid metal conduit that it's coating. This happens a lot if you have it lying out in the sun and it gets particularly soft. When you go to thread it, it'll just tear up that PVC coating. Then it has to be repaired or discarded. You can't use it that way. So it's best to just go ahead and cut that off with your pocket knife before you thread. Securing and supporting. It says rigid metal conduit shall be secured in accordance with one of the following. Rigid metal conduit shall be securely fastened within 3 feet of each outlet, box, junction box, device box, cabinet, conduit body, or other conduit termination. Fastening shall be permitted to be increased to a distance of 5 feet where the structural members do not readily permit fastening within 3 feet. Where approved, conduit shall not be required to be securely fastened within 3 feet of the service head for above the roof termination of a mast. Okay. All right, I think that's everything I wanted to show you. Here's part 3, construction specifications. Rigid metal conduit shall be made of one of the following: steel with protective coating, aluminum, red brass, or stainless steel. When they make it out of steel and they put PVC coating on it, it still falls under this Article 344 for rigid metal conduit. That covering is just that. It's just a layer of covering on the outside. All right, very good.